Today, Lesson 3, Unit 7, Interpreting Graphs. Yeah. Alright, let's start off. Meteorologists are scientists who study weather. They record weather data over days, months, and years. It is important that they display these data for others to understand. Yeah, because, we want to know how cold or hot it is. Especially when we're planning our trip here to Rankin Inlet in Nunavut. We want to find out when we should go. Depends, I guess, if you want to be cold or hot. Well, there's really never any hot. So, what does the graph show us? Well, the graph shows us looks like the average temperatures for a whole year and each month. There you see the months. There's the temperature. Ooh, nice little red dots and red line connecting them. Yay! So, let's start. What are some of the things that we can tell by looking at this graph? What can we interpret? Well, let's take a look at a couple questions here and see what they say. How do the highest temperatures in May and November compare? Well, there's May, and it looks to be about 4 degrees. There's November, and it looks to be about -4 degrees. They seem to be kind of opposites. Okay, that's something I've noticed. Which months have the same highest temperature? Well, let's take a look here. Looks like January here and December look pretty close. They both look about -13. Yeah, maybe around there, -13 degrees. Okay. We got October here and May. They look pretty close too. Okay. Which months have the same highest? Okay, we did that. And then obviously there's, what are 4 other things? Well, we can look at it. What are the warmest months to be there? Well, you'd want to go in June and July. Look at that. A nice 24, 25 degrees. Oh, I didn't realize it would get so warm there. Probably still gets down, probably -10 at night, probably. Anyway, so by looking at the data, we can discover lots of things and we can interpret lots of things here. This is something you need to be aware of. So we're going to move on to some more examples. Hard-Headed Helmet Company wanted to find out how many of its bicycle helmets had been sold in the last 6 months. Good information for a business. The company surveyed 10 bike stores in Manitoba. Okay, so here is the month. This is their tally chart and number of helmets sold. So in April they had 12, May they had 21, June 56, July 63, August 37, and September 18th. So we decided to graph it. There's our nice little graph. There's your y-axis, our x-axis. Okay, we got April, May, June, August, and July, and September, and there were the number of sold. Boop, 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 boop. All the dots are put in. It's all graphed, nice and neat. Neatness is a factor here, folks. Only whole numbers of helmets can be sold. You can't sell half a helmet. Let's be realistic here. So, for example, a store cannot sell 12 3/8 helmets. So the graph is a series of points that are not joined. This is important. So what they mean by not joined means that there's no line from April to May and another line, so the lines aren't connected because you can't sell part ways. You can only sell whole numbers here. So that means these data are discrete. There are gaps between values. Usually discrete data represents things that can be counted. Okay, so it ends. April, that's how many were sold in April. There's no in between April and May. So it just ends. So that's also how it can be discrete. From the table, we can see that the greatest number of helmets was sold in July. Yep, most, right there, 63. This corresponds to the highest point on the graph. Yep, highest point. This table and graph show how, okay, we're starting a new question here, so there we go. This table and graph show how Leah's height changed as she got older. Okay, so there's her age all the way to 10. There's her height. And once again, the other part of it goes all the way until she's 19. Here's the data. Nice and graphed. Ooh, they're connected. Ooh, something's different here. The data is not discrete. Ooh, wonder what happens. Well, I guess maybe because she continues to grow over the years. So you have months. So this is at age 2, but from 2 to 3, you have 2 in 1 month, 2 in 3 months, 2 in, you understand what I'm saying? There's 12 months. So the growth happens continuously. So that means we must draw a line. It's continuous data. Something else you should notice here, by the time she hits age 16, look what happens. She stops growing. Eventually, this here will continue along until she gets older, and then you'll see it'll start to dip down because you shrink as you get older. You can also notice some big, huge growth spurts too. If the graph was spun up a little bit, but the steeper the incline, you can see the growth. So looks like between 11 and 12, she had a pretty huge growth spurt. Anyway, let's continue on. So consecutive points on the graph are joined by line segments. Points on the line between the plotted points have meaning. For example, it is possible for Leah's height to have been 117.5 centimeters when she was 6 years, 3 months old. So this is the continuous data, it's not discrete. From the graph, we see that from 2 to 16 years of age, the line segments go up to the right. This shows that Leah's height increases. From 16 years on, the line segments are horizontal, which means she stopped growing. Okay? This type of graph is called a line graph. It shows continuous data. Continuous data can include any value between data points. Time, money, temperature, and measurements such as length or mass are continuous. Keep those in mind as you're doing the activities, which you're going to do now. So, as always, if you have any questions, you know who to come and see. Goodbye.